Uh, Today we will solve the problem 3.9 of Griffith uh, fourth edition Introduction to Electrodynamics. Before going into the detail, the problem 3.9 is in example 3.2. I have given detailed lecture uh, on example 3.2. In that, we assumed that the conducting sphere was grounded, that is V is equal to 0. But with the addition of second image charge, the same basic model will handle the case of sphere of any potential V naught relative, of course, to the infinite. What charge should you use and where should you put it? Find the force of attraction between the point charge Q and the neutral conducting sphere. So we have seen in detail in example 3, in which we have considered the charge q prime at a distance p from the origin. That is, this is p from the origin, and there is a charge at the point r at a distance r q is that is this is at, we can call it from the origin, it is a. The distance between the origin and q is a. This distance is a. So only a change here is we are keeping another charge q double prime at the origin. That is, here we are keeping the charge q double prime. This is the radius of the sphere, that is r. This is the radius of the sphere, and this is distance p. We are keeping the charge q at the distance p from the origin. Then what is this? This distance of q prime to q is naturally this is total distance is a minus b. This is a minus b. With that introduction, we will move on to our problem. So, in the sphere, the potential radius of the sphere, that is surface of the sphere, V is not equal to 0. V is equal to V naught, which is by definition 1 over 4 pi epsilon naught Q double prime. We have kept a charge Q double prime at the origin. So, Q double prime divided by R, that is radius of the sphere, that is V naught. The potential at the surface of the sphere is V naught, which is equal to 1 over 4 pi epsilon naught q double prime over R. So from this we can calculate q double prime. You bring all other factor to the right hand side, that is q double prime is equal to 4 pi epsilon naught R V naught, 4 pi epsilon naught. So we are moving this to the right hand side, this denominator to the right hand side. So you will get q double prime is equal to left hand side, q double prime is equal to 4 pi epsilon naught R V naught, and this q prime plus q double prime must be neutral. For neutrality condition, q prime plus q double prime must be equal to 0. That means q double prime is equal to minus q prime. So with that, we will move on further. The force between the charge q and q2 is q divided by 4 pi epsilon naught, and this q prime. This is kept at distance a from the charge q. So q double prime divided by a square, because the distance between q and q double prime is a. Then plus this, that is charge between q, force between q prime and q, q prime and q, we have taken as common factor outside. So this will be q into q prime, then square of the distance between them. So the square of the distance between them is a minus p whole squared. Now we got from this that q double prime is equal to minus q prime. So that you can take q prime outside as a common. So this will become minus. So q into q prime over 4 pi epsilon naught minus 1 over a squared plus 1 over a minus p whole squared. Now we got this expression f equal to q dot over 4 pi epsilon naught minus 1 over a squared plus 1 over a minus p whole squared. Now you take LCM, that is a squared over a squared multiplied by a minus p whole squared. Then you bring this here a minus p whole squared, which is equal to a squared plus b squared minus 2ab. Of course, you have negative sign here. Then you can bring this a squared here, so plus a squared. Now you can see this is minus a squared. If you add minus a squared and plus a squared will become 0. So the remaining thing is minus. You remember that there is a negative sign outside. Minus p squared minus p squared minus 2ab. So divided by a squared a minus p whole squared. So now you take p square p outside. So and if you bring this negative sign, this will become 2ab minus p squared. So you take p, then this will be 2a minus p, because we have taken negative sign inside, divided by a squared into a minus p whole squared. Now from problem 3.2 we know, from problem the example 3.2, not problem 3.2, from example 3.2, example 3.2 we have discussed it in detail. What is the charge we have to keep? What is q prime? According to problem 3.2, q prime is equal to minus r by a q, because this is image charge. So you refer my lecture on example 3.2. So I here before here we are replacing this q prime by minus r over a q. So we have replaced. Then what about p? In the same problem we discussed where to keep that charge. That charge we have to keep at a distance. P is equal to r squared over a. So I have replaced q prime as minus r over a q, and p is equal to r squared over a. Here also one p, minus r squared over a. In the denominator also one p, that is minus r squared over a. So now we will try to simplify this. Now we got this expression. Here you can notice that there is one q and another q. So you can multiply. You will get q square, and I am taking negative sign as common. This I am writing as r over a. Then what I am doing is, in the denominator you bring a squared inside the bracket. So this will become a, because already there is whole square. So the first term will become a into a squared, and second term this it goes inside the bracket, it will be a. So a will get cancelled. You will get a squared minus r squared whole squared. So we have reduced the denominator. Then what about the numerator? In the numerator you multiply and divide by a. So first if you divide by a, then you will get this a will become a squared. Each term I am dividing by a, dividing and multiplying by a. So this will become, if you multiply by this by a, you will get a squared. If you multiply this by a, you will get a will get cancelled. So you will get 2a squared minus r squared. 2a squared minus r squared. Here you have r squared multiplied by a squared because we are multiplying and dividing by a. So you will get r squared over a squared. Already there is one r over a. So this will become r over a power whole power cube. So you will get this q squared minus q squared over 4 pi epsilon naught r over a whole cube 2a squared minus r squared divided by a squared minus r squared whole squared. So you ignore the negative sign because we are finding the force of attraction. So you can ignore this negative sign. So you will get force without this negative sign. Thank you very much for watching my video and supporting me continuously. Thank you very much.